Happy Pi Day! I'm your host for Full Spectrum Science, Ron Hipschman, and this year we celebrate the 38th annual Pi Day. We take the whole idea of Einstein's famous tongue photo very seriously on Pi Day, and so do the Swiss. In 2020, the state-owned Swiss Mint issued a 3 mm, 1/8 inch diameter gold coin with Albert Einstein's face on it. It's the smallest gold coin in the world. Here's the other side showing the face value of 1/4 Swiss franc, or about 26 cents. Unfortunately, only 999 of these were made and were sold for 199 francs, about $70. It came with a special box with a magnifying glass on both sides so owners could see the famous physicist. Even though we have the Swiss consulate right next door to the Exploratorium on Pier 17, I wasn't able to obtain one. I looked it up online, and if you can find one, they're going for around $5,000. In 1978 and 79, the Swiss also struck two 5 franc Einstein coins, one with his formulae and one with his face, but no tongue. Your favorite pet can't resist emulating Einstein, or one of my fellow staff members' kids. Nor could my very good friend and astronomy professor Benjamin with his longest COVID Einstein hair. Or our very own Larry Shaw, the founder and inventor of Pi Day way back in 1988. This day is a tribute to him and his life. Pi Day has a nice Wikipedia page, and there you can find documented that Pi Day was first celebrated at the Exploratorium, and it was created by our own Larry Shaw. You can click through to find a nice bio on Larry. Larry built and placed the original Pi Shrine on the mezzanine of the Exploratorium back when the museum was at the Palace of Fine Arts. He placed it in the middle of the round classroom made of round cinder blocks. A very appropriate place, I think you'll agree. When we moved to Pier 15, we dedicated a new Pi Shrine. It's on the public plaza in front of the museum on the Embarcadero. Be sure to visit it and walk around it 3.14 times in celebration. We celebrate Pi Day on March 14th at 1:59. Reduced to its numbers, that would be 3-14 at 1:59. Compact it a bit, and you get the value of pi, or a decent approximation, 3.14159. Among other activities, at 1:59 we, of course, have our Pi Parade, where everyone has an Exploratorium yardstick topped by a digit of pi, appropriately written on a pie plate. We march down to the Pi Shrine to pomp and circumstance containing the digits of pi. We then circumambulate the Pi Shrine 3.14 times while singing Happy Birthday to Albert Einstein. And then we eat pie. But Pi Day isn't our only opportunity for celebration. Sometimes we celebrate 2 Pi Day on June 28th at 3:18, or 6/28 at 3:18. 2 times pi is 6.28318. And when we're feeling silly, we celebrate 3 Pi Day. 3 times pi is 9.424778, which would occur on 9/42, or September 42nd, or really on October 12th, if you carry those extra 12 days from September into October. In Europe, they write the date as day month, so they're limited to celebrating Pi Approximation Day on July 22nd, or 22/7. You may remember that 22 divided by 7 is a good approximation of pi, and indeed it is, 3.14285. Good to 0.04%. One of the most common places where pi shows up is in the famous formula for calculating the circumference of a circle if you know the diameter. The circumference, how far around, is equal to pi times the diameter, how far across, or in shorthand, c equals pi times d. By moving things around algebraically, we can see that pi is the ratio of the circumference to the diameter. This is true for every circle, no matter its size. For instance, if we start with this lovely pizza and some pepperoni, you'll notice that in this case, 7 pepperoni fit across the pizza. Well, if it's 7 pepperoni across, you'd also notice that it's 22 pepperoni around. The ratio of the circumference to the diameter here is 22 pepperoni around to 7 pepperoni across. Remember that 22/7 is a good approximation for pi, at least to 0.04%, which is good enough for pizza. And here you see it again. It's the same for all circles, pizzas, small, medium, large, and extra large. Pi is irrational. This means a few things. First, it cannot be written as the ratio of two integers, like our pi approximation 22/7. That's a ratio of two integers, so 22/7 is not irrational. Next, an irrational number has an infinite number of digits. Our approximation does have an infinite number of digits, but it also fails a third test, that it does not settle into an infinitely repeating pattern of digits. Here, you can see the repeating pattern of our approximation. Pi never repeats. You may have heard that pi is also a transcendental number. That doesn't mean that it has anything to do with Maharishi Mahesh Yogi and transcendental meditation, but rather pi, and all transcendental numbers, cannot be calculated with any finite series of algebraic operations. Every transcendental number is also irrational. Let's just move on. Pi has a long and storied history. If you look at Wikipedia's list of the chronology of the computation of pi, you'll find 119 record-breaking computations. We don't have time to explore all of them, so let's take a quick look at some selected bits. We'll see how important pi was to so many cultures. In Egypt, around 2600 BCE, a long time ago, they used 22/7 approximation of pi, and that got them quite far. 700 years later, in Babylonia, around 1900 BCE, they were using 25/8 as a reasonable approximation, only 0.5% too small. 1300 years later, at the time the Bible was written, around 600 BCE, we find the value of pi in the text of Kings chapter 7. And he, Hiram, made a molten sea, 10 cubits from one rim to the other, it was round all about, and a line of 30 cubits did compass it round about. Okay, remember our equations? 30 cubits around and 10 cubits in diameter gives us a value of pi equal to 3. We're losing some accuracy here, but we're still within about 5%. Archimedes came up with a brilliant geometrical method to calculate pi about 400 years later. He used polygons. He could accurately calculate the area of any polygon because you can break it up into triangles, and it's easy to calculate the area of a triangle. Now, Archimedes drew a circle so that it just fit inside the polygon. He, and you, can see the area of the polygon was bigger than the area of the circle. He then drew another similar polygon that just fit inside the circle. As you and he could see, the area of that polygon is smaller than the area of the circle. So Archimedes understood the area of the circle falls somewhere in between the areas of the bigger and smaller polygons, which he could calculate. Remember, the area of a circle is pi times the radius squared. If he could figure out the area, he could figure out the value of pi. Archimedes observed that the more sides the polygon has, the closer the areas of the two polygons approach the area of the circle. With many, many sides, you can narrow down the value of pi. Archimedes used a 96-sided polygon and calculated the value of pi to be between 3.141 and 3.143. Not bad. Moving to China, Zhang Heng in 130 AD declared that pi was the square root of 10, good to about 0.1%. He got a postage stamp for his efforts 1,825 years later. In India, Madhava of Sangamagrama in 1400 AD calculated pi to 11 digits and then 13 digits. Now we're getting some real accuracy. In Persia, present-day Iran, Jamshid al-Kashi in 1424 calculated pi to 16 digits. He also got a postage stamp for his efforts, and he only had to wait 555 years for the honor. Ludwig von Keulen, a German-Dutch mathematician, spent most of his life calculating pi to 35 digits using essentially the same method as Archimedes, except Ludolf didn't stop with a 96-sided polygon. He had 2 to the 62 power sides, or 4.6 quintillion sides. Incidentally, 35 digits of pi is way more than enough to calculate anything anyone could possibly use. More on that later. After his death, the Ludolphine number, pi, was engraved on his tombstone in Leiden. The tombstone was unfortunately lost, but later restored in the year 2000, which is what you see here. The first to use the Greek letter pi as a symbol for the number was William Jones in 1706. He took the first letter from the Greek word perimetros, meaning perimeter. But back to our calculations. In 1853, William Shanks performed the largest hand-done calculation to date. In 1853, he published 527 digits of pi. 20 years later, in 1873, after much more calculation, he expanded his accuracy to 707 digits. But unfortunately, because of an error at the very beginning of his calculation, only the first 528 were still correct. Even though that meant 20 years of hard work down the drain, it was still a magnificent achievement. John von Neumann, in 1949, found 2,037 digits with a calculation that took only 70 hours of computer time, not the 20 years of his life. He used the ENIAC computer. The ENIAC, or Electronic Numerical Integrator and Computer, was the first programmable electronic general-purpose digital computer. By the way, a modern iPhone has 6 processors that collectively run over 3.5 million times faster than ENIAC, and that doesn't include the graphics processor or the neural engine. And it fits in your pocket, but I digress. In 1958, François Jonouille calculated pi to 10,000 digits in 1.7 hours on an IBM 704 computer. In the modern era, 1 million digits were first calculated in 1973, 1 billion in 1989, 1.2 trillion digits in 2002, 2.7 trillion digits in 2009, 13 trillion digits in 2014, and 22 trillion in 2016. For the next two, I just want to point out a couple of recent personalities of Pi computation. On Pi Day 2019, Emma Haruka Iwao and the Pi calculating team at Google computed Pi to 31.4 trillion digits. And on January 29, 2020, Timothy Mullican, on a computer he built himself, calculated Pi to 50 trillion digits. His calculation took 303 days at a cost of about $10,000, which was only 5% of Google's $200,000 cost of calculation. Adding Emma and Timothy to the list doesn't quite complete it, however. In 2021, a Swiss team calculated Pi to over 62 trillion digits, and in 2022, Pi was calculated to 100 trillion digits by Emma Haruka Iwao and the Google team. I want you to notice something here before we move on. Look carefully at Emma's 2019 calculation. Notice anything familiar? It's the value of Pi in there. Pi times 10 to the 13th power digits. And the 2021 Swiss value is double that, 2 pi times 10 to the 13th digits. Lastly, let's bring it up to date. On 2 Pi Day in 2024, Jordan Renaud, Kevin O'Brien, and Brian Beeler announced they'd calculated Pi to 202 trillion digits. All in all, that's a lot of Pi. If we plot the number of digits calculated through time, here's what we get. Note that the vertical scale here is logarithmic, meaning for each vertical square, you multiply the digits by 10. Up until about 1950, the number of calculated digits grew rather slowly because all that work had to be done by hand. I'm not including those earliest years because the year axis is broken there. After 1950, the digital computer sped things up tremendously. By the way, a straight line on a log graph means things are growing exponentially, not linearly. 202 trillion digits of Pi is a lot of digits. How many do we really need? Voyager 1, launched in 1977, is the farthest human-made object from Earth and the first spacecraft to reach interstellar space. It's over 15.4 billion miles from the Sun, moving over 38,000 miles per hour. Light takes almost a day to reach it from the Sun. NASA uses 15 digits of Pi to calculate spacecraft positions. 15 digits gives us an accuracy of plus or minus 1.5 inches in Voyager's position. Remember, Jamshid Al-Kashi calculated Pi to 17 digits in 1424. Here's another example. Take the entire universe. We have a pretty good figure for the diameter of the known universe. Let's say we want to calculate the circumference of the universe to an accuracy of plus or minus the diameter of a hydrogen atom. The hydrogen atom is really, really small, 106 picometers in diameter, 106 trillionths of a meter. How many digits of Pi would we need to get this accuracy? Using our now familiar formula, we'd need only 39 digits of Pi. Pi Day has found its way into popular culture. It was first declared National Pi Day by an act of Congress in 2009. Let's take a listen.
House Resolution 224, resolution supporting the designation of Pi Day and for other purposes.
On this vote, the yeas are 391, the nays 10. Two-thirds being in the affirmative, the rules are suspended. The resolution is agreed to.
Moving internationally, the United Nations UNESCO in 2019 proclaimed March 14th of every year as International Day of Mathematics. Aside from Pi Day, pi has found its way into popular culture in Hollywood, too. In this episode of Star Trek, an evil alien has invaded the computer of the Enterprise. Spock has a way to keep it busy.
Ready.
Implement.
Computer, this is a Class A compulsory directive. Compute to the last digit the value of pi. As we know, the value of pi is a transcendental figure without resolution. The computer banks will work on this problem to the exclusion of all else until we order it to stop.
Yes, that should keep that thing busy for a while.
There was also a rather disturbing movie, Pi, made in 1998. A popular activity involving pi is seeing how many digits one can memorize. The current record holder is Suresh Kumar Sharma, who recited 70,030 digits. 9 years before that, in 2006, Akira Haraguchi, a retired Japanese engineer, claimed to have recited 100,000 places, but the claim was not verified by the Guinness World Records. What tricks can you use to remember pi? A useful trick called pi philology or Pilish is to make up a piece of text where the number of letters in each word help you to remember the digits of pi. Here's a sentence that will help you remember pi to a NASA accuracy of 15 digits. Notice the number of characters in each word. How I need a drink, alcoholic in nature, after the heavy lectures involving quantum mechanics. This is a form of what's called constrained writing. Mike Keith is a friend of the Exploratorium and a master of constrained writing. He paraphrased Edgar Allan Poe's The Raven to use the first 740 digits of pi. This is also called a Piem, but this was just the beginning. Here's Mike in front of his computer with the first 1,000 digits of pi. Mike also wrote an entire book, Not Awake, where the words use the first 10,000 digits of pi in all kinds of writing styles. You can get this book online if you want your own copy. Of course, stealing the form of haiku, a paiku has the familiar 575 syllable form, but about pi. Here's Paul Doherty's entry. A circumference, divide by diameter, irrational pi. One from Robert Foss. Pi Day's my birthday. Can I get free admission? Spent my cash on rent. And one last one from our own Ken Finn. Best pizza value can be found with this number. Make mine with mushrooms. And of course, there are limericks. This one's my favorite. If inside a circle a line hits the center and goes spine to spine, and the line's length is d, the circumference will be d times 3.14159. Now you, too, will begin seeing pi everywhere, like these M&Ms I found. Those aren't incomplete M's, they're obviously pies. From myself and Larry Shaw, the founder of Pi Day, I'd like to wish you all a happy Pi Day.